Welcome everybody to the new academic year and our first Metrans seminar of the semester. As most of you know, I am typically not the one standing in front to give any presentations because I like to feature everybody else who does work around here. We didn't have a person volunteer for September, so I decided to draft Sandeep, and I'll say a few words, right? Since it's the first seminar of the semester, I wanted to give some announcements of things that are happening in Metrans, and since Vicki, our Metrans administrator, knows more about that than anybody else, I'm going to have her make the announcements.
Well, welcome to the new fall semester. This is really an exciting way to start the year with not enough chairs and people sitting on little cushions up here. If any of you are kind of crowded, like you guys on the cushions, if you want a chair with a back, there are 2 seats up here and there's 1 seat right there. I wanted to just announce some of the things that are upcoming. And once you come to a seminar, which you have, we capture your email address and then we send you emails. So most of this should be familiar to you. And if not, by the second time you come to a seminar, if I'm telling you things that you haven't seen in the email, please let me know. For today, if you need more information, please email me. This is my email address, and I will send you out the announcements that you may have missed. So this is the first of our Metrans seminars series. This is a transportation research series that we have. Eugene, this is Eugene. There's food outside. We encourage you to come even if you can't make it right on time. So Eugene is one of the people who knows that we want you to come and sneak in whenever you're able to get here. So this is the first of our fall seminar series. We typically have 1 seminar a month. You should have received the schedule from me. The next one is coming up October 23rd. They're always a Wednesday, or almost always a Wednesday. We certainly make a point of telling you if they're not. They're at noon. And like today, be ready to watch for signs for a room change because sometimes we misestimate the amount of attendees and we need to move you for capacity. So look for our signs always look very similar to those yellow and red arrows that you saw this morning. The next thing we have coming up is our Urban Freight Conference. This is an international conference that draws researchers from across the globe to present their research regarding urban freight, which is one of the things for which Metrans is known. And we encourage you all to attend. Another place to go is our Metrans website, and I'll write that down for you when I'm done talking. It will also give you the information I'm about to give you about the Urban Freight Conference. It's in Long Beach, starts on Tuesday, October 8th. It has sessions for 3 days, ends with a really interesting site tour of a distribution center. It's a place where we can't even take photographs. It's so special and restricted, so I encourage you to look at the seminar or look at the conference schedule, and in particular make note of that site tour at the end of the conference. For students, we also have 2 ways that you can join the conference. One is you can register as a student and pay a nominal fee. The other is that you can volunteer. And if you take a volunteer position with us that could last anywhere from 2 to 4 hours, we allow you and encourage you to attend the rest of the entire 3-day seminar for free. So please let me know if you're interested in that. There are morning, afternoon, and evening things that you can do. Everything from manning a registration table to helping us set up, to actually being a room monitor and being assigned to one of our speakers and panels as our Metrans representative, which is a great opportunity for you to really get to know some of these people on a first-name basis. So I encourage you to look at that. We also tell you about scholarships, and you would be amazed at the amount of scholarships there are out there and the success that our students have, and they come with cash. So not only do you get to have an award that you can brag about, but you get some money to put towards your school. We have 2 scholarships with deadlines coming up. One is the Fitch Scholarship, or Ditch Scholarship, and that's due September 20th. Applications are due to them. So you've got a few days left. The other is WTS scholarships. Unfortunately for you men, this is one chance for women to get ahead, and they only give money to women. So men, encourage the women that you that you know to apply. And those scholarship applications are due October 7th. Remember that you have a lot of recommendation that you need to get, so you certainly don't want to wait too late to be thinking about those. And if any of this is new information to you, email me and I will send you out the information. Did I forget anything?
I don't think so. I think that's good.
Oh, one other thing I should mention. October 30th, we have another seminar. Normally we don't have them a week apart. This one is on a Thursday, and it's a collaboration between us and the Bedrosian Center of Governance. This one's really cool. It's a panel. Well, they're all really cool, but this one's really, really cool. And it's a panel on next generation transportation options, specifically talking about things like informal ride sharing, megabuses, and other ways that people get here and there, aside from either their personal automobile or a government bus.
Media-based, internet-based, arranged forms of transportation, either bus or various forms of ride-sharing or carpooling. And Professor Dusuki will be part of that panel.
When is that?
October 30th. It's a Thursday, a little bit different. And it will not be held here. It will most likely, unless so many of you come again that we have to get Boulevard Auditorium, it will be most likely at the University Club. And as soon as we have a really good handle on attendance, we'll let you know for sure.
Okay, very good. Thank you, Vicki.
Thank you.
All right, let's go to the topic of today's seminar. I think the reason you're all here is because I use the words big data, and everybody's really excited about that. This project is one of the first products that we have been able to generate after actually 2 years worth of research. So I think probably the research team is more excited than anybody else in the room that we are finally at a point of being able to present results from all this work. What we're going to talk about today is an application, one application of using the type of big data that we've been putting together here. And in this case, it's a case study of the LA Metro Expo Line. I'm going to do the intro, and then I'm going to turn it over to Sandeep Chakrabarty, who's a PhD candidate here in the school, and part of this research is part of his dissertation. I would be remiss if I didn't recognize all the people who are involved in this research. From the Price School, from the social science part of the house, it's me and Sandeep, and also Moja Rhodes, who's been working on this for a couple of years, and Udit Agarwal, who is in computer science, but he's the one that helps us to actually figure out how to deal with the data. We are a cross-disciplinary team. We have a whole group of computer scientists that have been involved in this work, headed by Cyrus Shahabi in IMSE. The person who I think has probably done most of the work at this point is Ugur Demirik, who's now the Associate Director of IMSC, and then Afseen Agdokan, who's a PhD candidate. So it's been quite a large team effort. Okay, so what about big data? Big data obviously leads to all kinds of new opportunities. The October 30th event is actually, one example of what happens when lots of people have access to lots of data. We're interested in the new opportunities available to social science, and in particular urban planning and policy. What we're going to talk about is what that means for us. We're going to then present our case study of the Expo Line. We're actually only going to give you kind of like half of the case study because we did an analysis, a very careful analysis of transit ridership. We also did a careful analysis of system performance. We don't have time to tell you everything, so we're going to focus this presentation more on system performance than on transit ridership. And then I'm going to come back after Sandeep does all that and talk about conclusions. Okay, I want to talk a little bit about big data and new opportunities. And in the transportation world, it's really kind of the merging of intelligent transportation systems and information and communications technology. And what that really gives you is sources of very highly disaggregate data with both respect to time and space. Some of you may be familiar with, for example, GPS trace data. If we can have access to your smartphone, sort of like the NSA, right? Then and you have GPS, we can track absolutely everything that your phone does, and presumably you along with it. There's roadway sensor data, all the sensors in the roadway that you probably are all familiar with, right? You look on sigalert.com before you would even think about getting in your car, and that's all generated from data in the road network. Another example is accelerometers, which are little things that you wear, and we can track how much you move, so we can measure your physical activity. So those are all ways in which we are able to obtain data that we actually were not able to obtained before. So the question is, what kind of opportunities does that give you if you have access to this type of data? And I'm going to focus primarily on the sensor data, which is what we've used more. We don't use GPS or accelerometers in what we're going to tell you today. Most of it is sensor data. Well, if you're a transportation modeler, you really love having access to real-time data, right? Because it's going to allow us to do a way better job calibrating various types of transportation system models or simulation models. And this actually has gone on for quite a bit of time over with my engineering colleagues, okay? Real-time transportation system management. So this is what the MTA and everybody else does with this data. They use it to actually manage the system. And as we've gotten better at this, right, we can actually intervene in real time to better manage a system. So the very advanced traffic signal systems, such as the city of LA's, actually can intervene and in sort of real time accommodate changes in traffic flows. That's all great, but what about social science? Okay, and so for us, what we're really interested in is travel behavior analysis in various ways. How do we get the data to understand better how people behave and travel? And transportation system analysis, what can we do to better understand the way the transportation system as a whole behaves in the face of various types of perturbations? So now let me talk about what we have. What we have is what's called the ADMS, the Archive Data Management System. And this is a database, a gigantic database, that contains this transportation system data from the LA metro region. The data structure of the database that we have created has been created by our computer science side of the team at IMSC. They were very interested in the project because it created a lot of computer science interesting questions, like how exactly do you manage to swallow 40 megabytes per second worth of data? Okay, that was something that hadn't been done before. And another question is, how can you design a constantly growing database, you know, because we're getting new data every single 30 seconds. And how do you do that and still have a database that can be queried efficiently? Okay, so there was a great deal of new computer science that went into the development of the database itself. Our job over here on the social science side of campus was to develop applications, right? Because the purpose of this project is to say, well, if you have this data, how can it be used usefully not only for us who are interested in the research, but for the practitioners, the people who actually are providing the data in the first place. the value of ADMS is that it has so much in it, and of course we're adding more to it to make it even more valuable. So first of all, it has multiple modes. This is not just the Caltrans state highway system stuff that is the basis of the anticipated travel time information that you all get on the 110 freeway or something. It's not that. It's not just that. We also have arterial data, and we also have public transit system data within the archive. It comes from all kinds of different devices. It's not just sensors. We have camera information, closed-circuit TV information. We have the transit automated vehicle locating system, in other words, the GIS data from the transit system. We have line data, etc. It comes from many different agencies who have all come together, and I'm going to explain that in a little bit, to create the real-time database in the first place. And it has all types of different data in terms of durations, type, size, etc. So I believe at one point our computer scientists figured out that there were 15 different types of data that had to be accommodated in this system. Okay, so where does it come from? It comes from RITS, the Regional Integration of ITS, what is this called? Kelly knows the name. And I want to actually recognize there's a whole bunch of people in the room from LA Metro. Do you want to raise your hands right now? Okay, this is the LA Metro contingent. They were the sponsors of all this, or they are. And they are actually the lead agency that put together this RITS group. These are some of the members of the group, and who all decided that they would share data, right, in order to be able to better manage the transportation system. So this is a purely voluntary effort on the part of these agencies, and there is a committee of agency representatives that basically monitors how this data is used, and they kind of peripherally are linked to this project in that way. In addition to all the stuff that came through RITS, we have collected a bunch of other information that was outside of RITS, and in this case, the bus and rail data is the most important stuff. This is probably the most important graphic, I think, to try to convey the idea of what's so great about this data. And so I have a time axis and I have a space axis, and I have various types of data plotted in this world of time and space, okay? And here I am with what I have in ADMS. I have everything at an XY coordinate, so it's precisely located in space, point level data. And I have everything in as short as 30-second intervals, okay? So you can see that I can aggregate to any time period I want, you know, minutes, months, years, etc., decades. And I can also aggregate to any spatial unit that I want, right? So I can use a block, a census tract, a city or a county or whatever, okay? The point is that because the data is here, I can do anything at all that I want with it, okay? That's very different from the kind of data that you and I and everybody else, all the social science people in the room, really have at our disposal. So here, for example, if we were back in the old days, this is the transit ridership that we'd be able to have access to. Annual reports of transit ridership at maybe a city or a county level, okay? The census data that we all use a lot comes out every 10 years. So the time is extremely large, right? But I can get census data from block level and I can aggregate up from there. Okay, so there's all these things in the transportation engineering world. There's something called HPMS. All transit highway operators have to submit a certain amount of information to the federal government for performance monitoring. That's another annual. right? So this is the first time that we've basically been able to have the entire coverage of that graph. What does the system do? I think to sort of give you a little bit of background in terms of what this does. It's designed to support 3 different types of queries that we call monitoring, ad hoc, and statistical. And we have examples of what those queries would be. The important thing here is that the way that the computer scientists figured out how to handle this data was to dump this stream of data, right, into something called the fresh data store. Okay, so this is essentially a temporary storage of data. And then at the end of every 24 hours, everything that's in here gets mapped into here, the comprehensive data store. Okay, the comprehensive data store is huge. It's 2 terabytes now, something like that. But it's in the terabytes, okay? And so what that means is it's really hard to query. It's hard for us to get any data out because it's so huge. And so what the computer scientists are working on now is this thing called the summary data store, where essentially they are creating what are called data cubes that are parsing this data in ways that make it much easier to query. Okay, so when all of this is done and we're actually ready for prime time, we're going to be using this part of the system more than anything else. Okay, so at this point, we haven't seen much of this kind of research in urban planning. And so what we've wanted to do with the data is to show how we can use these resources in varying applications. There are many things we could do with them, right? And of course, the hope is that using data in these ways, we can make much better policy decisions. And I think now it is Sandeep's time.
Thank you.
We'll get to the real research here.
Okay, so the application that we are presenting today is a case study of the Expo light rail line, the phase 1 of the line, which is an 8.6-mile line connecting downtown LA with the west side, terminating at Culver City. So I'll start with giving a background of this study. So I can, okay, thanks. So essentially what we are doing is we are doing an impact assessment of a light rail transit system, right? So what does theory and prior literature tell us? Actually, what we know from literature is that light rail investments are associated with great expectations, but very little evidence of real great impacts, right? Light rail transit systems are high-quality transit systems, and they're promoted nationally in order to provide better quality transit services, in order to increase transit patronage, and thereby, and also attract more auto users to use transit, and thereby reduce congestion, save energy, and also promote more compact and sustainable urban forms. And therefore, a large amount of research effort has gone into exploring the land use, urban development, and local and regional economic development impacts of light rail transit systems. And the evidence that we have is that the results are quite mixed, and essentially the impacts of these light rail transit systems are unclear when complementary land use policies, zoning policies around stations and along the route, and also market forces are factored in. The reason is that most of these light rail transit systems replace pre-existing bus services, and the addition in transit capacity is generally small compared to the total traffic and travel demand within the corridor. So, and also there's very little change or in regional accessibility that's provided by the light rail transit system. So, I mean, should we expect huge impacts on transit use, travel behavior and traffic? So what we know is that it may or may not generate more transit patronage and may or may not influence urban form. But more fundamentally, what we don't know from prior literature is what impact LRT systems have on congestion within the corridor they serve, and also on transportation system performance. So this is the route alignment. Most of us are aware of the route alignment of the Expo Line. Essentially, it connects downtown LA with Culver City. This is the first phase, but into the second phase, it's going to be extended further west into Santa Monica. So the Expo Line was intended to provide and actually improve access and mobility of residents and employees. This is from the environmental impact report, which includes the traffic impact assessment as well of the LRT project done back in 2005. And it was intended to provide an additional transit alternative, thereby increase transit mode share and consequently alleviate congestion. And it says that the freeway essentially operates at a level of service F for more than 3 hours of a day with very high volumes, and that the Expo Line is key to congestion reduction. And therefore, this sort of is the background and context of our study where we need to evaluate what the real impacts are. Now, theoretically, can we really expect the Expo Line service to have a significant impact on mode choice, transit use, and consequently system performance? Well, we think that at least there are 5 prerequisites. The first is the increase in transit capacity should be significantly large compared to total traffic and travel demand within the service corridor. There should be a substantial increase in transit's level of service, which of course the Expo Line does provide, because the Expo Line service was associated with concurrent changes or reorganizations in some bus transit services. So that we do see a significant increase in the level of service, of course. The third is there should be an existence of a latent demand for high quality transit travel, which has to be greater in magnitude than the latent demand for auto travel. And we know that in highly congested corridors, there is a high latent demand for auto travel. So any capacity freed up due to mode shifts from auto to travel may be easily replaced with additional traffic because of this latent demand. The fourth point is the route alignment should be appropriate. We are not exactly, we can't comment whether the Expo Line has the best route alignment possible. We are not sure, but that's what it is. And the fifth point is it shouldn't have adverse impact on roadway traffic conditions. So what ad-grade rail services does is that it changes intersection signal timings and things like that. So it's possible that it adversely affects intersection conditions, right? So the research questions that we're asking is, has the Expo Line generated more transit use? And if it has, then has it been translated into an improvement in mobility and reliability of travel across its service corridor? And we adopt a quasi-experimental design. That's the closest that we can go to an experimental setup, where we have identified experimental and control corridors for comparisons, and also before and after period comparisons. This is a map of the corridor, the test corridor. Now, so the test corridor consists of the 10, which is this one. The 10 is essentially the spine of the corridor, and there are multiple parallel routes connecting the west side with downtown Los Angeles. Now, this test corridor is divided into the experimental and control parts. I'll come to that. Now, a corridor, loosely speaking, consists of multiple modes and routes connecting two geographical locations. And here we have this corridor which connects employment and residential locations on the west side with similar locations in downtown Los Angeles. This region is highly dense in terms of population and employment. And it suffers from high levels of peak period congestion during peak hours in the morning and afternoon. So what the Expo Line has done is that it has added a transit alternative in this particular corridor. Now, the experimental part of the corridor is delineated based on our understanding of the routes that can potentially be affected by any sort of system performance changes induced by the Expo Line. And we have two control groups. The control group to the west consists of regions, areas in the future extension area of the Expo Line, and a region further north, which is far enough so that we do not expect any influence of the Expo Line on the control corridor. Now, the experimental corridor is also chosen based on another study that's been conducted under Professor Marlon Burnett, which involves before-after surveys of residents near the Expo Line station. So it's not exactly the same experimental corridor, but it includes those households as well. Now let's look at the data. So we'll talk in a little bit about how big the data is, really, that we have used. But we have used 2 time points for our preliminary analyses. The before period is a 3-month period from November to January 11-12, and the post-expo period, November to January 12-13. We've used transit data. The transit data that we've used includes GIS data, planned service operations data, headways, and number of buses per line and things like that. Patronage, boardings, and alightings pretty fine-grained at the stop level for a given line at different time points of the day, and system performance measures as well. We won't show the results for system performance, but we'll mostly focus on patronage. Regarding sensor data, we have the highway and arterial sensors. We had like 16 million plus records for the highway and 180 million plus for arterials. So this was the magnitude of the data set that we have used. I'll briefly talk about sensor data cleaning, because the thing is, when we have big data, we have big problems as well, right? We have bigger problems of missing data, and we have huge amount of noise that needs to be cleaned and filtered off before we can use this data with a reasonable level of confidence. We have Udit here. Udit did an excellent job in applying these filters. So essentially, what we did was we looked at we had theoretical expectations regarding the relationships between speed, volume, and occupancy, right? So based on those expectations, we performed several filters, and after performing the filters, we were left with around 40% of highway data and 29 to 30% with respect to what we could have had ideally. Now, why is that? Because not all sensors work all the time, and not all data are reliable enough. So we had missing data problems and noise, right? So after cleaning the data, we, as units of observation, as Professor Giuliano explained, that we can aggregate at any levels temporally, right? So we used 15-minute intervals as our unit of observation. So for a given sensor, we can have 96 observations of speed or volume or occupancy on a given day. So we aggregated records, and of course, within a 15-minute interval, if you have no data points available, you just don't have data for that 15-minute interval. So the percent of missing data that we have in our database for this analysis ranges from around 35 to 40% for highways and 14% for arterials. What we didn't do was we didn't impute values into the missing cells, I should say. We left them as it is, and whatever data analysis that we present are with data that we have. So first I'll talk about the impacts on corridor level transit use. So the question is that, has the Expo Line, and remember that the Expo Line was also associated with some concurrent transit service changes, like some reorganization of routes, not many, and also headways of buses were adjusted and things like that. Some lines were taken off. So whether the Expo Line has had a significant impact on transit ridership or use within the line service corridor. We've performed 4 analyses. First, we have looked at change in bus and rail boardings at all stops and stations in the experimental and control groups before and after. Second, we looked at change in average weekday ridership of east-west transit lines through the corridor. Why are we interested in east-west transit lines? Only because those are the alternate routes of the Expo Line, and those are sort of, I mean, in terms of connectivity, these lines are the lines that are sort of similar to what the connectivity that the Expo Line provides. We've looked at change in person throughput, because what we also have is person throughput data. So for example, at a given stop, the data set doesn't only tell you how many people got off and got on, but how many people were there on the bus and sort of crossed through a particular screen line. And we also looked at transfers, which I'll explain in a little bit. And we have accounted for all the service changes, and we know that all major service changes were concentrated within the experimental area. Now, okay, so let's spend some time on this. So this is a map of our test corridor with the experimental and control parts. So for the first analysis, what we have done is we have looked at transit boardings at different time points of the day. We have only considered peak periods. We have compared transit boardings, aggregate transit boardings at all stops and stations within the experimental group with the control corridors. In the second analysis, we have only looked at the transit lines that run east-west. We have looked at changes in ridership. Note that the ridership of these lines, we cannot attribute everything to as activities within the corridor. So these are line-level ridership changes. So it's possible that ridership changed because of activity at parts of the line which are outside our corridors. Okay, so this is the first analysis where we looked at the change in bus and rail boardings. What we observe is that within the experimental area, we have a 6% increase in transit boardings compared to a 4% decrease in the combining both the control areas, which sort of suggests some positive impact on transit use. Now, as a second part of the analysis, we looked at the weekday ridership of the east-west lines through the corridor, and what we observe is patronage for the east-west lines through the experimental area that includes the Expo Line in the post-Expo period, of course, increased by around 7% compared to a 2% decrease in the control group. However, we do see a change or an increase in revenue hours of service, so the change in ridership was associated with more service too. So there is positive impact, but service increased as well. As a third comparison, we looked at throughput. So throughput is sort of an efficiency measure, right? So we observed that within the experimental area, and we had the screen line along Western Avenue, and we looked at throughput across that screen line in terms of transit passengers, and we observed a net close to 14% increase in the experimental area compared to a 6% decrease in the control areas combined, which again is some evidence of positive impact on transit use.
How reliable are those numbers? Are they plus or minus 1%? What should I believe in your numbers?
Well, for the transit numbers, we haven't really done those tests. Yes.
I don't know whether it's good. I don't know whether I should read them because.
Well, the difference was significant.
What?
The difference.
Yes, for the there they are.
They're significant. Well, the other way of putting it is your N is so large that these numbers aren't going to have much fluctuation per se.
N is not that large.
N is not large.
Oh.
Because of our aggregation.
Well, for say for example the east-west transit lines, we may have like say 13 transit lines through the experimental corridor and like 6 transit lines in the east-west direction through the control corridor. So N is not large. So these are just comparison of aggregate ridership.
Cases I thought would be large.
That's for the sensor data for traffic, but for transit these are aggregates.
Significant, I should worry. Very fine. Okay. No, I mean.
No, absolutely.
I just don't know what to do with it.
Right.
Keep going. We don't have much time left.
Right. So then we compared transit activity within walking distance of transit stations. So what we observe is an increase in transit activity in terms of boardings and alightings at stops within a close walking radius of the stations, which again suggests that there has been a significant increase in bus transfers within close walking distance of the Expo stations, and the magnitude of these changes sort of suggests that this change cannot be due to changes in, say, demographics or regional employment. So we do think that a lot of Expo riders are drawn from feeder transit lines. Now,
I have experience on your example of La Cienega.
That's right. Yeah.
There are two things that I wanted to add. Lots of transfers there.
Right.
And two, if you look at the people on the lines, they are not likely to be auto users.
Okay. Right.
I mean, I don't count, but I mean, it's typically elderly folks or poor or students. So.
Right. But the other thing that we looked at is if there are more transfers, if people are using the Expo by transferring from or to the bus, to feeder or connecting transit lines or transit bus lines, are they new transit users, or are they making, they used to make transfers to a competing bus line, parallel bus line to the Expo line? Well, if there were new users, we would possibly have seen an increase in ridership of the connecting or feeder bus lines, which we don't observe. So it's possible that a significant number of these passengers who are transferring near transits near the Expo station used to transfer at a different point on the feeder bus line. Say, for example, you used to transfer on Venice, but now you have the Expo line, so you transfer to the Expo line, right? So it's possible that some Expo riders are drawn from existing bus transit users. Now, our conclusion is that the Expo line seems to have had some positive impact on transit use, and the results indicate some amount of latent demand for high-quality transit service, transit travel, and we also have some evidence of transit mode substitution, which may not be large enough, substitution and mode shifts as well, because we do see an increase in overall transit patronage, but are these changes large enough to have had a significant impact on corridor level traffic? So, yeah.
Go back to this one.
Yes.
So this is kind of surprising. You said the previous results showed that ridership went up. You said it was a positive impact on ridership. That's critical.
That's right.
It's not coming from the feeders. Does it mean that the ridership is increasing because people are now going straight to the station? That the only increase of ridership? Because if you would have seen, because the feeders actually went down.
It's
whatever. It's not true.
Right.
So basically, all the increased ridership is basically due to people walking, getting out of their cars and walking to the parking. So that's when you look at your results.
You mean the change in ridership of within the corridor?
Transit, you said basically your aggregate, because your next bullet, if you look at your next slide, your bullet says ridership goes up.
Right. So when you look at,
if it's not coming from the feeders, then it must be coming from.
It is well, now these are feeders connecting the Expo line. So what we are saying is, now we have more transfers near Expo stations, right? Now, if we have more transfers, it's possible that the increased activity in terms of boarding alightings at bus stops near Expo line, it may be due to a change in the demographic composition of the neighborhood. It can be a result, this increase can be a result of changes in employment and things like that, that people of the neighborhood are riding more transit. But it could also be that people who were...
So what is the direct station
It's a
connector?
shifting.
Yes.
What this shows is that there's less activity on the feeder lines, but more activity on the direct station connectors.
Right.
So if you're a station that directly connects with the Expo line, you've got more activity. If you're a stop that didn't connect with the Expo line, you got less activity. So it's an indicator of shift.
Right.
So the direct station station connectors still feeder lines?
They are still feeder lines where you don't have to walk.
Right. The first one is
Right.
it doesn't connect to the Expo at all.
Right.
Exactly. So it's within a walking radius. Right. Yeah.
Okay, now what I'm going to suggest, in view of time,
Right.
is that we skip the I-10.
Okay. We can go straight to,
arterials.
yeah.
So go ahead and talk.
Okay.
right?
So, yeah, I mean, we had, you know, done comparisons for the freeway, the Venice Boulevard, and all east-west arterials connecting downtown with the west side. Now, we looked at two different performance measures. We looked at corridor level speed and also at travel time reliability, and at two different time points within the AM peak period and the PM peak period, which, again, the definition of the AM and PM peak periods were based on our you know, analysis of traffic trends within the corridor. Now,
I'm flipping.
right, we can go to here. Yeah, right. So let's look at the Venice Boulevard. Yeah, let's look at the Venice Boulevard. So essentially, as part of our experimental setup, we identified you know, an arterial that's close enough to be significantly affected by the Expo Line's whatever changes in system performance that's the Expo Line as an impact of the Expo Line. So we had this experimental segment and the control segment of the Venice Boulevard. And so first we look at changes in peak period speeds. So now we have two peak periods, AM and PM, and we have two directions of traffic, east and west, and we have two groups, that's experimental and control. Now the story is that if you look at the mean difference in difference, what it shows you is the relative increase in speed at a given time point, that's AM or PM peak, in a given direction, relative to a control group, relative to the pre-Expo period. So essentially what we observe is that in the west direction, both in the AM and PM peak, we observe huge relative increases in speed for the experimental part of the Venice Boulevard. Now, but if you look closely, these relative increases in speed or relative improvement in mobility along the Venice Boulevard is due to decreases in large magnitude, decreases in speed in the control segments, right? So you know, in terms of magnitude, speeds along the experimental part didn't really increase, but there were large decreases in speed in the control group. Now, do we really believe this? We don't know. We really looked at this data. We sliced the control group in terms of space and time, and we see this huge decrease in speed in the control group. Several things can happen. First of all, the huge decreases in speed can be due to you know, construction activities for Expo Part 2 in nearby arterials, and more traffic was diverted onto the control part of the Venice Boulevard, and therefore there's this decrease in speed. So we're not certain. However, we see, and we also did this difference in difference regression, where we see statistically significant increases in speed for the experimental corridor, part of the corridor.
Okay.
So we also looked at reliability now as a comparison of buffer times. Now buffer time is defined as the difference between the 95th percentile of the travel time distribution and the mean, which is essentially the additional time or time cushion you should keep in order to reach your destination on time, right? So that's a reliability measure. So we compared reliability measures for the experimental and control corridors in both peaks, in both directions, and we do observe minor but significant improvements in travel time reliability, again in the same direction, that's the west direction, and it's possible that this improvement is attributed to deterioration in traffic conditions within the control group, right? So so it suggests some positive impact. Now, as the last piece of this study, we looked at parallel arterials, and We don't have an experimental control group here because most of these arterials don't have sufficient sensor data going west in the control parts that we were interested in. However, these arterials that are far away from the Expo line can be sort of looked at as controls. So say West 3rd Street is far enough that we don't expect that it would have any significant impact due to the Expo effect, right? And we observed that mostly speeds decreased. However, we see improvements in speed closer to the Expo line, right? And this is consistent, I think, with Professor Burnett's study, where you observe significant decreases in VMT at households in the post-Expo period, right? And we observe, sort of consistently, we observe increases in speed or an improvement in travel conditions along arterials which are closer to the Expo line, which suggests that Expo impacts are more concentrated in terms of space, right? They're spatially concentrated near the Expo line, which sort of is intuitive. So Professor Giuliano would talk about the conclusions.
Okay, I'm going to go through this really quickly because we've talked about everything here, that we really do have a lot of evidence, we think, that, the Expo line did in fact have a positive impact and a net increase in transit use, and probably a little bit more than proportionately than the service increase that accompanied it. We kind of think that at least some of from our evidence that at least some of that ridership was already on transit, but also there's some evidence that suggests, right, that some of these are also new trips. So that's good news. We can't talk about it. We also have been doing work on reliability, and one of the things we find, of course, is that trains are much more reliable than buses, and that may explain some of the shift as well. In terms of system performance, the short story was that on I-10 we found absolutely nothing, and we wouldn't expect to, right? Because the I-10 carries 250,000 vehicles a day. Surely, if 10 people got off there and rode the Expo line, we certainly wouldn't find it. And we did, we think we've got some evidence here for improved performance along arterials. Truthfully, we probably figure that that can't last because of constantly increasing demand. But nevertheless, we've shown that at least there's some evidence that it can happen. Probably, from our perspective, more interesting here is the fact that we've shown, we think, how this kind of data can be used for analyzing impacts of actual policy decisions, infrastructure investments, and so on. Certainly data limitations exist, especially for the arterials. We were very disappointed that we found that although there were sensors that were marked on our control place on the west side, none of them were working, or none of them were giving us data, I should say. So, that was a problem. And of course, our story is still incomplete because one of the things we haven't been able to measure is actual person throughput. And why? Because there's no auto occupancy data. But we managed to at least do something here, right? So what I wanted to get to is this. Certainly, we think that using this type of data has a lot of potential to improve our ability to monitor and to analyze major projects. As I said, it's very highly detailed across time and space. It really reduces the cost of performance monitoring. We can do the Expo line for 6 months. We can come back and do November to January 13, 14. We can do all kinds of things. We can keep this going as a panel. And so you have just unlimited opportunities to conduct these types of evaluations. The other thing that we've learned is that big data, of course, is only as good as what's generated at the source. There's a great deal of missing data. There's a lot of reliability problems, right? And so you have to really learn the nature of the data and figure out how you can fix it so that it can be of use to you. And then, of course, not all critical or interesting data are collected. Much of our transit analysis was actually the result of us collecting other data from other sources and merging it with what we had in the ADMS system. The third point that my students can certainly verify is that if you're going to get into this business as a social scientist, right, you're going to have to learn some new skills. And those are about programming and database management. So we have gone through the pain, right? We're elementary users of SQL now. But it really is something to think about from an education perspective. That's it. I want to, one last time, thank LA Metro for funding the project. If they hadn't funded it, we wouldn't be here today talking to you about it. So they deserve at least as much applause as anybody else. So thank you very much. We do have time for questions, a few questions. And I'll start here.
Hi, Stephen Hubbard, DVD program. Have you guys looked at sensor fusion out of the military and like battlefields, CQ guide systems? Because they've been grappling this.
Yeah, you don't know about this. Yes, there's a lot of things you could do in the sort of data fusion world. We haven't gone that route yet. I don't think we actually, in terms of
Well, I was thinking more of struggling with the volume of data and how to sort of process it and then set it up for future
that's all
processing.
The computer scientist's job.
Oh, okay.
We leave it to them, and they're really good at it. Andy.
As a colleague, this is great work. I think it's it's a step in the right direction in terms of transportation research using big data. Having said that, I have two comments. First, you already talked about this missing data problem. I mean, you have more than 30% missing data, and I'm not sure if you have actually looked at the missing data and found any patterns in it. Have you done any analysis?
Yes.
Yes, have.
Does it tell anything about the data? And because it may significantly affect your results, depending on how you impute the data, how you have different strategies to leave out the data or impute the data, and there are all sorts of different literature to deal with missing data. I think it's very critical.
Yeah. Do you want to say anything?
Yeah, I mean, our computer scientists, the team, they are working on how to develop strategies for imputing, and they have some developed strategies to impute. But for our study, we didn't impute. Regarding patterns, well, what we did observe is that sensors, these are sensors not working, right? So that's generating missing data. And sensors don't work for long periods of time. It's not that sensors suddenly wake up and then die down. That's not the problem. So we have this problem of sensors not working and not being repaired for considerable durations of time. So that's the pattern that we have observed. So we are not worried about unreliable data being thrown out by the sensors at certain points and then dying down. So that's not what we observed.
The other issue actually is when you have such huge databases, the kind of biases that you might worry about when you have, let's say, 2,000 observations is really very different than when you have millions. So we are actually on another piece of this research that we're doing where we actually want a representation of the entire regional system. We're going through a completely different process to generate such a sample, taking into account the missing data. So, yes, thank you for the comment. Yes?
So, in light of the fact that I think generally it's been found that transit doesn't have a huge impact on car congestion, at least in cities of this density, just because any people that come off the road, someone else is just going to take their place eventually. So this was largely framed in terms of congestion reduction for drivers. Are there plans or hopes to do a study more in terms of improvement for people who switch from driving to transit or people who are currently using other transit like buses and the improvement in travel times and reliability and so forth for them? The people who seem to be most likely to really clearly and consistently benefit from these kind of investments?
Your dissertation.
Yeah, we are looking. We are actually looking at the benefits that such reliable, high-quality transit services can bring about. So the point is that you're right. I mean, it's possible that not a lot of people have come out of their cars to get into the Expo Line, but we do observe a lot of transit mode substitution, people from the bus getting on the Expo Line, right? And that's, at least in part, is due to these qualities in terms of more speed, more reliability, more comfort, right? I'm not sure if it's more safe, but yeah, but the other dimensions. So we are looking at the influences of these service quality parameters on the benefits of transit users and how it actually benefits transit users. Of course it does, right? So we are trying to quantify that.
Another kind of dimension to your question is actually if we're talking about making improvements in the system, then we would really like to see that the system as a whole is improved, right? And so it's actually good to know that the system didn't, you know, the automobile part of the system did not deteriorate, okay? At least not yet. And certainly there was nothing that was done in terms of the transit service that made things worse for the rest of the system. In addition, we have to conclude that the throughput, even though we don't know how many people are sitting in cars, right? It sort of looks like the throughput, the number of people who are being served in the corridor over a period of time is increasing, right? So by doing this kind of thing, we can at least indirectly point to the kinds of benefits that we hope that these investments do have on the system. Yes.
So did you think about, to include the collect the data for demographics or education? Because I assume that some people, they no matter how good the system is, they just won't change because time is more valuable for them. So I'm wondering whether you can collect data and kind of control for demographic or education. Yeah,
this is an aggregate level analysis. Yeah. Professor Bornett is doing the hard work of the individual behavior, right? In his, we are actually adding demographic data to the database for other purposes. For example, to look at whether shifts in transit use are geographically, right, are related to the demographic and employment characteristics of those geographic units. Yes, sir.
So this was like a follow-up question on Andy's point about missing data. I was thinking, I noticed there is 2 different periods you were observing for this project. One is the pre-Expo Line period, and the other is the pro-Expo Line period. So how do you deal with all those consistency of data? Because we know the Expo Line cannot be built in 1 year or 2 years. It must be a very kind of long period of construction. How do you think about if there's change in data quality, like there is some kind of advance in the technology of cars, people are more willing to drive cars than take the mass transit within this 5 years period. So how do you deal with those consistency?
First of all, this was a 1 year. It was 3 months in year 1 and 3 months in year 2. And there's really no reason to believe that the vehicle fleet so dramatically changed in 1 year, right? If we were doing this over many years, then we'd want to definitely take into consideration those kinds of factors. You have any?
No, yeah, and I mean, whatever changed in that time is transit service, and we incorporated that in our calculations. So, of course, I mean, there were some transit reorganizations made, and we factored that in. But in terms of vehicle fleet, we won't expect a lot of change in a year, right?
Yes, sir.
Very good presentation, thank you. I noticed on most of your graphs, except for the one you're talking about, the connector services, you presented in terms of percentages changes, and I'm looking for the bottom line total riders in the study area, if that actually did increase. And kind of complementary to that is, I like the way you presented it, that these are indicators of potentially showing this and that. do you have an idea from looking at the data on number of riders, not just number of boarding rides? So,
number of riders, yes. So you mean
rides? Somebody who's making a trip from, they used to be able to take a single seat ride, and now they have to board a bus and a train, so they're counted twice. So maybe
yes,
that might be influencing the data. So
absolutely,
do you have some factors that you
absolutely. We don't actually. I mean, these are all. There is no way of really capturing the linked trips that you're talking about. So a person may make a transfer at one point, but it's part of his single, his or her one longer trip to the destination, right? And that's counted as 2 trips. You're absolutely right. So.
Well, this is all APC data.
APC.
Passenger count data.
Yeah, so these are passenger
so
counts.
So this is boardings and lightings.
So you're right.
And estimates of what the passenger volume is on the vehicle itself. Sure.
that was somewhat addressed.
Right. But, so what you're also saying is that, is it that due to the Expo Line, people are making more transfers
and then
than
it's just an artifact?
Yeah, I'm just wondering the difference in activity versus total new riders. That, like, you can have good indicators for lots of that.
What was the comparison in the region?
The region?
The regional increase in transit ridership?
It was 3% increase.
And this one was?
This one was more than that.
So compared to the region, it's receiving a lot more.
Yeah. But yeah, we agree with you. I mean, if you had a way of measuring that, that would have been great. Not double counting riders. That's totally true.
One last question. Yes.
Were similar studies done, because LA has just expanded so much its metro rail system through multiple lines and other lines? And if they were, did they help in, I guess, like framing some of the questions you're asking, or creating, discussing outcomes for a larger county level than just the Expo Line corridor?
I don't think so. I don't think there's been other studies like this. We actually picked this because it was a really good example of being able to do a a quasi-experimental design kind of study. We would like to, once phase 2 opens, we'll want to do that. We want to keep tracking this. And there are many other applications that you can think of, right, that we could do. We also picked this one because the core of LA, it has a greater density of sensor data than any other area. So we decided to pick one that would have a lot of data at the beginning. But yes, we can. This is basically a county-wide and in some ways region-wide data set. Okay, well.
I think you can get better results now.
Sorry?
I think you get better results now. Because look at that study period. The Expo Line wasn't in business for long.
That's exactly right. I mean, that's a good point. In the after period, the average ridership per day was 16,000 and something, right?
Yeah, it started with that.
In our data here, it's 27,000 now.
And you also put the period, which is actually a low travel period.
Yes, but it was, yeah.
That's right.
March here and get better results.
Right.
Yeah, and we didn't have the data when we started. So, that was the earliest period we could take, and in order to get started, we had to cut it off. So yes, we could spread it out and we'd probably get better results.
Right.
Yeah. More data. Okay, thank you very much.